Hi there. Thanks for joining us. Andrew Dunkley here, the host of Space Nuts. And coming up on this show, it's jam-packed. We're talking about Sagittarius A star, the black hole at the centre of our galaxy. Well, it looks like it's spinning at near its maximum rate. So what does that mean? And should we put the cat out tonight? We'll also be looking at how some planets may have received their water via Pebbles. And a couple of lost items, a lost space rocket. Well, it wasn't lost. We know where it is. It's everywhere. And a tool bag lost in space. Also some audience questions about habitable moons, quasars, and dark matter stars. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9... Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to discuss all of that and probably more is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. How are you doing? It's good to see you.
Well, yes, good to see you too. I've been away for a couple of weeks actually. Took the grandchildren up to the Gold Coast and did the theme parks, and I actually achieved 0 G while I was away. I went on the Hypercoaster, which is at Movie World. It's one of the biggest roller coasters in the Southern Hemisphere, if not the biggest. And the way it starts, it goes up you get dragged up the ramp, and then you usually hesitate at the top and then go down a steep slope. Well, this one doesn't stop. It goes straight over the edge. It actually goes beyond the vertical. It comes in and in before it goes out, and your stomach just leaps forwards out of you.
But it doesn't.
It's the most horrible feeling. And the thing reaches 100 kilometres an hour in a couple of points.
Sounds suicidal, Andrew.
It felt like it while we were on it. I love roller coasters. I've done a lot of them, but no, that's it's huge. It takes a long time, that one. Usually it's a pretty quick ride, but you get halfway through it and go, I've had enough.
Yeah.
But
when you went on that sort of more than vertical drop, do you think you were in free fall? Were you
felt like it just very briefly, because you don't feel any weight in your seat because you're actually falling
you're being
to the ground.
Yeah.
And the carriage that you're in is kind of behind you. It's really, it's a very unnerving feeling. Yeah. But and I must confess, when I got off and my son got on it with me, we both felt a little bit of motion sickness at the end.
I bet you did.
Zero gravity. See, that's what it was.
Yeah, they don't call it that aircraft the vomit comet for nothing.
No, it's a really strange feeling. But yeah, probably one of the most violent roller coasters I've ever been on.
Mm.
Yeah, didn't take the grandchildren on it. No.
I think I'll give that one a miss. Thanks very much for offering, but I think I'll give that one a miss.
Well, they don't let 200-year-olds on it.
No, well, there's that as well. Yes, that's right. Because then your stomach really does leave, the rest of you.
Everything just falls out. Yeah. I wasn't sure. It's been a few years since I was on a roller coaster. I just wasn't sure how I'd cope with it. But yeah, I was okay. Eventually.
The one in fact, it's probably the last one I was on, which was in 2011, when I was involved with, we did a segment on Channel 10, is it, here in Australia, on 60 Minutes, about the Large Hadron Collider.
That's Channel 9, I think.
Is it? Yeah, it might be Channel 9. I can't remember. Anyway, 60 Minutes, we did a segment about the Large Hadron Collider, in which I was trying to explain what it was for and what the Big Bang was all about. But in order to give our viewers a sensation of what it might be like being a subatomic particle going around the Large Hadron Collider at 99.999998% of the speed of light,
it
put us on a roller coaster at a place called Col de Fossile, I think, which is just outside Geneva.
Wow.
And this thing it is fairly spectacular. It goes up a hillside and you plough your way to the top and then come down and it's not quite the same as what you've described. It's the curves in it that are the bit where your stomach goes one way and you go the other.
Yeah.
But what we did was we hooked two cars together with a cameraman in one facing backwards, and I was in the other one doing a running commentary on what was happening while we went round these corners.
No, thank you. Well, I probably would do it.
Yeah, you do it.
All right. Well, now that our stomachs are back where they should
yes,
be.
I'm sorry, that was a digression. You can cut that out, Hugh, if you like. That's
Let's talk about something else that's been lost other than our lunch, and that is a tool bag from the International Space Station. Apparently, a couple of astronauts were out doing a job, and whoops.
I let go of it in the wrong direction. So I did look at this, but I can't remember the details. But I think it was an ESA.
Might have been ESA.
The ESA astronauts who were involved because, of course, they're partners in the International Space Station, doing some work outside, just like the stuff that's going on downstairs at our place at the moment with lots of tool bags around, but they let go of that one. And that one's a bit difficult to get back if it drifts away. And so what surprised me about it is that it's drifted away. I think it's drifted ahead of the International Space Station, if I remember rightly. Excuse me. It will eventually burn up. It'll just gradually, its orbit will decay and it'll re-enter. But it must be a big tool bag because apparently it's bright enough to see with binoculars.
Wow.
I haven't checked up on that yet because all the apparitions of the International Space Station over the next week or so here are all at 4:00 in the morning, which is just a little bit early for me. But it means so it's around about seventh magnitude in terms of in astronomical magnitude terms. 7 is about the limit of naked eye visibility, but with binoculars you probably would see it. You might need a darker sky than we have actually here in Sydney. Anyway, it's something to look for. Those, people out there with a telescope or telescopes are not so good for looking at the International Space Station because it moves too fast, but binoculars are all right.
I've got binoculars. I'll give it a try.
Yeah, give it a try. You've got a dark sky out there in Dublin as well.
Yeah.
Dark.
And I do tend to get up fairly early most days, but not quite that early.
Well, it might be you might have a different set of apparitions there because you're significantly further west than we are. So that you check it out on Heavens Above.
All right.
Anyway, yes, the lost tool bag. So its orbit will decay and nobody's going to get it back.
I think the funny part was they said, but it doesn't matter because we didn't need it anymore at that point.
Yeah, that's right. I saw that too.
It probably only cost $1 million.
Yeah, that's right.
No worries.
I know. I don't know why we're laughing, Andrew.
No, we shouldn't be laughing. Space junk's a big problem.
Yeah, that is what it costs $1 million a shot as well.
Who knows? I'm pretty sure it wasn't a $20 tool bag from Bunnings. Or Home Depot if you're in America. Another kind of loss was SpaceX recently with a bit of a rocket disassembly, as they're calling it.
It's what's the term? A rapid unscheduled disassembly. That's the term.
I love it. What happened? Do we know?
Yeah, well, it's. I haven't seen the detailed results, but certainly the first stage performed flawlessly. Actually, that gigantic, what's it called, the Falcon Super Heavy?
Yeah.
All 33 of its Raptor motors were firing throughout the flight. That's better than they had last time. I think they had 2 that went out. So they had kind of full thrust all the way up to, was it about 45, 50 kilometers? And then the separation of the second stage, which is the Starship itself. This is the bit with the round nose and the fins on the front. That separated, okay. But shortly after that, there was an explosion because the idea was to bring the Falcon super heavy back to Earth and probably land it in the Atlantic.
Yeah.
But it exploded. And they think the reason for that is something to do with a new technique that they've got. I think they call it hot firing, if I remember rightly. When the second stage leaves, they fire up the second stage motors before they detach it from the first stage. And so you've got the full thrust of this thing playing on the on the old first stage. So I'm not surprised it exploded.
Yeah.
But then something went wrong with the second stage after that. They had, it was a significant amount of time it was firing under its own propulsion. They were going to land it back on a barge north of Hawaii. It was going to go almost around a complete orbit, but there was an explosion before that happened. Everybody seemed very upbeat about it in SpaceX, because that's, this is Elon's tried and tested technique for improving things. You build it and try it out. If it doesn't work, you think again and build it again. And when you've got a lot of money, that's what you can do.
Yes, he'll be able to get another Falcon Super Heavy from Bunnings for $20, I think. So.
Yeah. It might not have all 33 of its Raptor engines.
Maybe not. Yeah, don't think they carry that line anymore. What I read was that despite the mishap, NASA was still quite impressed with the whole exercise.
Well, and the other thing is that this time it didn't trash the launch pad, which it did before.
Yes, it did.
The first one. It basically wiped out the launch pad, and I think bits of debris rained down on people downrange from the launch, which didn't impress them. So there's so there was certainly an environmental aspect to criticise SpaceX on that one, but I think they've tidied up their act, and so it looked as though that was much better. In fact, for a lot of that launch, Andrew, all systems were nominal,
but until they weren't.
Until they weren't. That's right.
Yeah. They'll get it right. That's the way of this industry, isn't it? You keep trying things, and if you make a mistake, you learn from it and go on.
It is in the private sector. NASA's got to do things differently because they're spending public money, and
exactly.
So they are far more risk averse, far more cautious. And I think the two techniques, side by side, work well because, of course, Elon SpaceX is actually contracted to NASA in a big way. In fact, that Starship is what's going to land astronauts on the moon year after next.
Elon reminds me of Gomez from the Addams Family crashing his trains into each other.
Yeah.
Sorry, Elon. My apologies. All right. But yes, not a total disaster in any respect.
It was a rapid, an unscheduled rapid disassembly. It was exactly what they said it was.
All right, moving on. Let's talk about Sagittarius A star, the black hole at the center of our galaxy. Now, this one we're interested in because it's ours. We own it. No other galaxy has this one. This is ours. We took possession of it before the French. But anyway, it's spinning as black holes do, but they've now announced that it is spinning at a rate near maximum. What is maximum for a black hole? Is that the speed of light?
That's a good question, actually.
I tried to research it and got all sorts of weird answers.
Yeah, this is the trouble. As soon as you get into the theory of rotating black holes, you're in quite difficult mathematical territory, and often the things that you're looking at don't seem to make much sense. And in fact, the spin of a black hole has this, it's defined as being a parameter whose range is from 0 to 1, where 0 is a non-rotating black hole, 1 is one that's rotating at maximum rotational speed. And I suspect that you're right, that you're limited by the speed of light. The thing is, it's the black hole that's rotating, not necessarily the event horizon. So it's all kind of very touchy-feely stuff is this, but touchy-feely in a very strongly mathematical sort of way. But anyway, you're right. Some work that has been published in that well-known journal, the Monthly Notices of the Royal Astronomical Society, by scientists principally in the USA, I think. One is at Penn State. I think that's the lead author. They've basically pinpointed the rotational speed of the black hole, and this is a speed parameter. It's a kind of rationalized number that just gives you an idea of what the speed is, as I said, from 0 to 1. And they reckon it's between 0.84 and 0.96. And the top limit is 1. That's pretty well, getting onto its maximum speed. There's the tricky thing, and I guess what makes it so interesting from a mathematical perspective and difficult to get your head around from anybody else's perspective, it's the way the spin's defined, because a black hole doesn't have dimensions. Other objects like planets, like anything in space, stars, whatever, they've got physical surfaces, and you can deal with you can understand the rotation of a body in terms of what it does to its physical surface. In fact, as we're sitting here in New South Wales at the moment, Andrew, our linear velocity is about 1,400 kilometres per hour eastwards by the rotation of the Earth. So we're moving eastwards at that speed. And the fact that we don't notice that made people believe that the Earth was stationary and at the centre of everything back in the day. Yeah, we don't think that anymore. Whereas with a black hole, it's just it's a region of space-time. It's got the event horizon around it, beyond which nothing can escape, and it's all about the way the gravitational forces behave in the region of the black hole. So you get basically a twisting of space-time. And there's a new term that I have seen before, but I'm not really very much across it. It's called the ergosphere. The ergosphere is that region of the space-time around a black hole that's curved by the black hole itself. As some of the physicists that are discussing this in the article that I was looking at, which, by the way, is on Live Science, they were discussing it, saying the ergosphere is something that's unique to black holes. So a solid body like a planet doesn't have that, and it's all. And then the next thing that comes from this is something called frame dragging. So that as they spin, the black holes twist the fabric of space within this ergosphere. So the ergosphere is a bit like the event horizon, but it's different. It's about the frame dragging effect. We do know that solid bodies do this frame dragging, because I do remember a few years ago we had the Earth's rotation, the way it drags space-time around with it.
Yeah, well, I remember talking about that.
Yeah, that's right. It had been detected. But it's very different with a black hole. And, it's why black holes act like gravitational lenses. You get very strange optical effects because of the gravitational influence of the rotating black holes. Very strange things, rings of light, black hole shadows, all of that stuff. So it's worth. I'd recommend any of our listeners who are interested in following up on this. The Life Science article is very, very well written, and gives a lot of detail about it. And
I almost understood it.
Well, I thought I did when I got to the end of it, but as soon as you stop reading, you don't. Anyway. So it is. It's an extraordinary discovery that you've got this thing, which is about 4.5 million times the mass of the Sun, Sagittarius A star, is spinning at this enormous rate. It's quite extraordinary. It's really quite an extraordinary phenomenon, and we basically have this. I don't know. How do you get your head around something that's got that much mass that's spinning at nearly its maximum speed?
I know. I know.
Yeah.
One article I read said that it's not unusual for a black hole to spin at 1,150 cycles per second.
When you think about. Sorry, go on. Yeah.
No, that's just an unthinkable speed.
It is, but that's typical of the speed of a neutron star. the rotation speed of a neutron star, which is not a black hole, but it's not much different from a black hole. A neutron star is, neutrons compressed together to give you this incredibly high density. So the mass of a star compressed into the size of a city. And they, because of the fact that their magnetism lets them beam out radiation, we get this lighthouse effect, and we get what's called a pulsar. And millisecond pulsars, ones that spin at more than 1,000 times a second, are pretty commonplace. So it's not that hard to envisage that a black hole could spin even faster than that, because they're much more compact.
Fascinating. Of course, it has a very big effect on its local environment, and the more that goes into it, the faster it gets. I mean, could it reach one? Is that possible? Do we know?
It's probably possible for it to reach one. Yeah. That's an interesting question, though, whether as a black hole accretes material, as it gobbles stuff up, which ours is doing at a fairly modest rate. It's not doing anything horrible, turning it into a quasar or something like that. But if it's accreting, does that increase its rotation? I would guess it does, because, intuitively, if you put more mass near the center of something that's rotating, it rotates faster. It's a conservation of angular momentum.
Yeah. Well, you just
as witnessed by... Yeah, go on.
I'd probably say the same thing. No, I was going to say, just ask a P-plate to put more fuel into the engine and the wheels go faster.
I wasn't going to go there. I was going to go with the office chair analogy, where you spin on an office chair. If you have your legs out and then pull them in, you spin faster.
Yes, the ballerina theory.
And the ballerina theory, that's right. Yes. You don't need to go to P-platers. We could do it all in an office.
They're much better at spinning wheels, though, and not moving. Yes, right. All right. If you'd like to chase that up, livescience.com, as Fred mentioned, is the website. This is Space Nuts with Andrew Dunkley and Fred Watson.
This episode is brought to you by Dragon Ball Legends, the ultimate Dragon Ball experience on your mobile device. Dragon Ball Legends features action-packed anime action RPG gameplay with Goku, Vegeta, Trunks, and all your favorite Dragon Ball characters. Summon your favorite characters from popular Dragon Ball anime series, such as Dragon Ball Z and Dragon Ball GT to Dragon Ball Super. Fight in real time against friendly or rival Dragon Ball players from across the globe in live PvP battles. Enter ratings matches with your favorite Dragon Ball characters and earn rating points and rewards. Unite with friends to defeat powerful foes in co-op. Dragon Ball Legends features the best anime fighting scenes on your mobile device. And now, Legends Festival is on, so you can get up to 300 free summon tickets. Are you ready? Download Dragon Ball Legends today. Available for free on both iOS and Android devices.
3, 2, 1.
Space Nuts.
Righto. Fred, I remember, a little while back, you and I talked about how Earth might have got its water. And, of course, popular theory was that it was delivered by asteroids, and some of it probably was. But a new theory came forward that suggested it was probably already there when the planet started forming, and accretion created the planet, and the water was already there, and voila, we have oceans. But now this is a little bit of a variation on that theory, I suppose you could say. New information through James Webb Space Telescope suggests that some planets, maybe even ours, could have received their water via ice-covered pebbles. This is interesting. Yeah,
so it's a theory that I think has been around for quite a long time. That says that as you form planets, you accrete material, just as you said. They gradually, it starts off as dust and gradually builds up to pebbles. And then the pebbles gradually accrete one another and get bigger objects, eventually get what are called planetesimals, which are maybe 100 kilometers across or something like that. They bang into one another. You get heating because of the collisions, and stuff sticks together, and eventually you end up with the solar system. It's all sounds a bit rough and ready, but that's the way it worked. But there are subtleties on those theories, Andrew, and one of them is basically that while you're forming planets, you get pebbles of material that essentially drift from one bit of the solar system to the other. So the theory is, and once again, perhaps I should set the scene a little bit on this, because we think that beyond what we call the snow line or the frost line, that's the distance from the sun where water would freeze. Yeah. Beyond that, you've got ice. Within that, you've got water vapor. And as you know, that delineation is kind of between the orbits of Mars and Jupiter, and that's a very neat division of the solar system, and it's all to do with the snow line or the frost line.
Do we have just as a matter of interest, do we have a mush zone where it's not quite ice and it's not quite vapor, like we do on Earth?
Yeah, that's right. It's yes. I mean, we used to experience that a lot when I lived in the Northern Hemisphere in Britain. You get snow, and that snow's lovely, but then it turns into mush. It's not lovely. We call it slush, yes. And slushy days were by far the worst. So there might be a short slush line or mush line. I should write a paper on that, Andrew. Actually. Yeah, really good in the monthly notices of the Royal Astronomical Society. The solar system's mush line or something.
But anyway, I bet it exists.
I bet it does too. Notwithstanding all that. The idea then, if you've got pebbles that drift in from the outer solar system, why can't they be covered with ice, which would then bring the water in towards the inner solar system, where you're getting, rocky planets forming, and suddenly that water becomes the oceans of the Earth, or at least becomes accreted into the young planets. So this theory has been, as I said, it's a fairly old theory. It's called the icy pebble drift theory. I love the name. And what we have now, and the reason why we're talking about this, is that there is a new paper which is being published in the Astrophysical Journal Letters, whose title is JWST reveals excess cool water near the snow line in compact disks, consistent with pebble drift. It's a long title, but it's basically the James Webb Telescope has found water sort of where you would expect that those icy pebbles to be delivering water to the inner solar system or to the inner region of the planets. Mm-hmm. One of the authors, there's a nice quote here. I'm actually looking at Universe Today. Our old friend Universe Today has got a very nice piece on this. But the quote is from one of the authors of the paper itself. Webb finally revealed the connection between water vapor in the inner disk and the drift of icy pebbles from the outer disk. This finding opens up exciting prospects for studying rocky planet formation with Webb. And that's excellent news. So the bottom line is these authors studied four young stars, sun-like stars, with their protoplanetary disks still intact around them, and looked at the way the gaps in the disks and the kind of abundance of water vapor within those gaps, whether that supports the icy pebble theory. And the bottom line is that it does. And so really nice. It's been done with MRS, which is the medium resolution spectrometer on board JWST. It works in connection with MIRI, the mid-infrared something instrument. I can't remember what it is. So we've got these many different instruments on the Webb that can actually detect water vapor, as well as looking deep into these disks. So very, very nice work by these scientists, and maybe it is a breakthrough in the question that we've had many times: where do the Earth's oceans come from? Well, as you say, it's probably a mixture.
Yeah, another interesting aspect of this I notice is that this only applies to standard sized planets, rocky planets. When you get to bigger planets, the pebbles can't drift, and therefore that gets locked in. as far as I can tell.
Yeah,
Because
which
of different forces at play.
That's probably right, and so that is kind of what we find in the region of our solar system where the gas giants are. So that you keep the stuff there if you've got giant planets forming. Yeah, it's planet formation is a complex business, and we grossly oversimplify things as well as sympathise with them and space nuts. But you can tell that there's a huge amount of really significant work going on in this field, and I think we're a long way down the track of really satisfactorily answering the question: where did the Earth's oceans come from? As you said, a mixture of perhaps asteroids and comets colliding, plus this, what you might call indigenous water that came on the pebbles that actually formed the planets themselves.
Yeah, I think it makes sense that it would be a combination of factors. It's not like someone turned up with a big bucket and went, "There you go, $10, please." Water was a lot cheaper back then. But there's got to be a combination of factors at play, I would think. And this one sounds like, wait for it, this one sounds like it does hold water.
I like it though. I like it. It's got promise. I won't tell you to give up your day job yet.
Oh dear.
And it's
I probably
Miri,
won't
of
have
course.
to give up my day job. They'll just say, "Out, off you go."
Miri, of course, is the mid-infrared instrument. I was overcomplicating the acronym. It's the mid-infrared instrument.
Okay. If you'd like to read on more about the icy pebbles giving water to the planets, universetoday.com, as Fred mentioned, is a great place to start. This is Space Nuts. Andrew Dunkley here. Fred Watson there.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to our question-answer session, but we're going to start off with some homework. We got a question from Buddy recently about how is it that gravitons can escape from a black hole when nothing else can get out? And we kind of pondered that and went, "No, too hard. We'll go and ask somebody else." What did you find out?
Yeah, Quora is, of course, the thing you go to when you want questions answered. Sometimes they give the right answers and sometimes they don't. But the question on Quora, which was probably placed a few years ago, can gravitons escape the event horizon of a black hole? If not, how can we detect the black hole's gravity? And we've got an answer from actually a graduate student whose name is Barak Shoshani, at the Perimeter Institute for Theoretical Physics, one of the top institutions in the world for this kind of work. And basically what they're saying, what Barak is saying is that gravitons don't escape the event horizon, but they don't need to because the gravity that you feel is all about the curvature of space-time. So you don't need to know what's going on inside the black hole in order to feel the curvature of space-time outside it. And there's a subtlety as well in that gravity. So I guess what Buddy was thinking of, and I would have done too, this is Buddy in Oregon, was that, you kind of align gravitons with photons, that they're similar things because they're both massless particles, but they've got fundamental differences, and it boils down to one being nonlinear and one being linear, and that's where my understanding stops. Basically, the idea is that there are subtle differences between gravitons and photons, but it is interesting that you don't actually need gravitons to feel gravity, because the bending of space-time is what makes the gravity real.
Okay, there you are. Buddy, I'm sure you'll have another question for us based on that, because whenever it comes to black holes, they just keep going around and around, sometimes at very high speed. Thanks.
Almost well.
Yeah. Almost. Thanks, buddy. Hopefully we filled in the blanks on that question. Let's go to an audio question now from Obi.
Hello, Fred and Andrew. This is Obi here from the frozen tundra that is Tasmania. So I'm just going to get straight to my question. I've been making a mod for the game Kerbal Space Program, which is just basically a space flight simulator, and it's basically going to add, an expanded new solar system, which is something that's been done multiple times over before. But anyway, I'm doing it anyway, and I want to make it as realistic as possible. But one of the planet systems in it is basically a habitable moon that orbits a super Earth. And I'm just wondering if that's even possible. Like, would there be something preventing, like, tidal forces or having it form in the first place? But yeah, is that scientifically feasible? I know you can have them orbiting gas giants, at least in theory, but what's preventing one from orbiting a super Earth? Thank you.
Thank you, Obi. Obi from Hobie. I've got a feeling I know
I have to explain that one.
Hobart, Tasmania. Yeah, okay. I think I know Obi. I think we talked about Obi's book a couple of years ago that he wrote as an 11-year-old, if I remember rightly, about the future of space travel. I reckon it's the same guy.
Okay, well,
yeah, lovely to hear his voice, if that's who it is. I'm pretty sure it'd be pretty unusual to have the same. Yeah, there wouldn't be too many Obis around. Oh, there's Obi-Wan Kenobi, of course. Yeah, forgot about that.
Yes, I was going to say, there's that.
But he's asking, is a habitable moon orbiting a super Earth possible?
I think the answer is yes. Backtracking slightly, Kerbal is fantastic. I remember when he was younger, it's probably 10 years ago now, my younger son Will got heavily into Kerbal. And I was so impressed with the way that it really replicates how space flight works. It's not, it's not a game where you've got rockets just zooming around willy-nilly. This is real gravitational navigation of spacecraft. And it is, it's like what you do is you launch things and see how far they'll get, and then they crash. And it's just like what Elon does for real.
I was about to you make me tell it.
Yeah, but it's it's great stuff. So it's a good thing to play with, and I'm sure it's come on by leaps and bounds since Will was involved. I'll be seeing Will this weekend, so I might check up with him whether he's still a Kerbal enthusiast. But the bottom line is, moons are certainly possible around the gas giants because we've got plenty of them. And if a super Earth is something not much bigger, it's somewhere between the mass of the Earth and the mass of Neptune or Uranus, which are the ice giants. They're smaller than the two big gas giants. They've got moons around them. Some of them are quite large. If you put it in the right bit of the solar system, then maybe those moons will be habitable. So I don't think, Obi, that you're stretching physics too far to envisage habitable moons around super Earths or even larger planets. I think it's just extending it once again into thinking about the solar system. We've got, for example, I know it's not a super Earth, it's a gas giant, but Saturn with its moon Titan, which has got such an interesting story to tell, a rocky world with an ocean overlying it and then an ice layer on top of that with methane and ethane lakes in the ice. That could be, it's not habitable for us because the temperature is about minus 190 Celsius. But there could well be organisms that thrive in that sort of environment, and that's why there's interest in sending spacecraft to actually have a look at Titan, a closer look.
Not to mention Europa and Enceladus.
Yes, and that's right, the ones around Jupiter and the other moon of Saturn that's of great interest, Enceladus, Europa around Jupiter. The reason why Titan's so interesting, though, is unlike the others, it's got a really thick atmosphere.
Yeah.
And so its atmosphere is active in the sense that it's got a water cycle, except it's not water, it's liquid natural gas that vaporizes and rains and forms lakes and rivers. Extraordinary world, just extraordinary. Perhaps one of the most bizarre places in the solar system, but very interesting in terms of what kind of organisms might live there if they do.
If they do. So the answer, Obi, is yes. So forge ahead. Design your solar system. Sounds like fun. And lovely to hear from you. And I hope your future prospects in space science are moving forward, because I know you're very enthusiastic about it. If you're the Obi I'm thinking of, and I think you are. Let's go to a question from Peter. Peter has emailed us. He said, I've read or heard that quasars are one of the most powerful energy sources we know of. I'm also aware that matter entering a black hole's event horizon slows right down, even freezing from an external viewpoint due to relativistic gravity effects. Shouldn't this mean that the energy emissions are drawn out for a huge amount of time, if not indefinitely, at a correspondingly lower intensity? My brain is having trouble reconciling those effects, so I'm sending the job to a higher brain. Well, we rang God and he couldn't answer. So, Peter, we've asked Fred.
Oh, dear. I think there's a higher brain than me lying on the floor here. He's called Geordie and he's a black poodle. Anyway, I think that the issue here is that the energy that you get from quasars is actually coming from the highly energized material in the accretion disk. It's the disk of debris around the black hole. So it's not the stuff that's landed on the event horizon. It's this swirling mass of stuff around the black hole, some of which is indeed disappearing into the black hole, and no doubt getting frozen on the event horizon, exactly as Peter says. But it's the energy of the accretion disk itself that causes quasars to be so bright and gives you these jets of relativistic particles moving upwards and downwards perpendicular to the accretion disk in quasars. So yes, highly energetic objects which behave in a way that you can kind of get your head around, I think, as long as you realise that it is material outside the event horizon that's actually emitting these copious amounts of energy.
Okay. Thank you, Peter. We've got a double header here from Brody.
Hey, y'all. This is Brody from great state of Florida. Got two questions for y'all. And one's serious and one's kind of funny. First one is, what do you think on the possibility of dark matter stars? I'm interested in these. I was reading the article earlier. Thought it might be a possibility, but wanted to get your thought on it. Second one is, what is your favorite conspiracy about space? Mine is the face on Mars that was captured way back when. I think it was funny, but been proven wrong. Let me know. Thanks for the show. It's always great.
Thank you, Brody. I'm not sure about part two. I haven't really given it a lot of thought. I'll try and come up with something while Fred answers the first part. But dark matter stars, we have talked about those before. We haven't found one yet, have we?
Yeah, that's if I remember rightly, we did talk about this a few weeks ago with the notion. I think there was a candidate because it turns out that a dark matter star would not just be dark matter, it would also have normal matter in it and would become fluffy and very large. I think that was the story. I can't remember the details of it. But, you know, it to me, this raises the whole bigger question of the exciting possibilities for dark matter, because we don't know that dark matter is just one species of subatomic particle. There could be many different kinds of subatomic particles that constitute dark matter, just like there are constituting normal matter, baryonic matter.
Yeah.
dark matter particles could exist in forms where you get chemical reactions between them, and certainly where you could get nuclear reactions between them. So a dark matter star, whilst I think you're right that a genuine dark matter star has not been observed and there aren't any candidates, nevertheless, it's a realistic possibility.
Okay. All right.
And my favourite conspiracy... Sorry.
Yeah.
The face on Mars was great. And
they made a movie out of it. Was it Red Planet or was it the other one, Mission to Mars? But yeah, it was a fabulous science fiction about the face on Mars turning out to be the people that created life on Earth.
Yeah.
So I'll just spoil that. Sorry.
No. It's 1976 was when it was observed. It was the Viking orbiter.
Yeah, I remember that.
And yeah, it did look for all the world like a face, and it was so convincing and had so much sort of conspiratorial backing to it that it was kind of almost mandated for NASA. The next time they put an orbiter into orbit around Mars, the first orbit, or within the first few orbits, they had to steer it over the face on Mars to get an image of it with a much better camera. And that's when when the whole thing disappeared. It clearly isn't the face; it's just a hill with
rock,
many valleys in it. It's quite big; it's a few kilometers across.
Okay,
but yeah, that's a good one. But Mars has had many of these what you might call conspiracies with images that look like something else. They're called, what's the word? Mimeolith, I think, or something like that. A rock that looks like something. It's all part of. I've forgotten the name of the phenomenon.
Yeah, me too. I was just trying to remember it.
It'll come to me in a minute. Anyway, where we see things and recognise them as looking like something else. It's got an EIA ending, I think. Anyway, never mind that. We're both struggling. That's because we're both old men, Andrew.
Yeah.
Some of us are older than others. So it's very common to find things. I've seen headlines: a tire on Mars, a top hat on Mars, a grey lady on Mars. The best one was a recent one, which was a doorway into a rock on Mars, and it was just the way the image had been taken, I think, by Curiosity or one of these spacecraft.
Okay,
you're still trying to think of the word, aren't you? So much.
Yeah, I am. I can't think of it. It's terrible. Thing is, last week it popped into my head that exact word. I was thinking because I saw something and realised it wasn't anything at all. It was like a rock or something. But,
yes.
And it happened to me before we moved here. We used to go for a walk every day, and every day I thought I saw a duck stuck in a drain grill.
Right.
And it was just the mesh around the grill that it was sticking out of the ground. But even though I knew it wasn't a duck, every time I looked up, I thought, "Oh, there's a duck." Oh no, it's not. Drove me nuts after a while. I should have cut it off. Mine, I think my favourite space conspiracy is the fact that a lot of people still believe the moon landings were faked. They even made documentaries about it. Yeah. I had the pleasure once of interviewing Buzz Aldrin, and he has a real bug with this one. In fact, he got into a couple of punch-ups with people over this particular claim. He can't stand the fact that people think that it was all faked and he was a part of it. He stuck to his guns on that, to his detriment a couple of times, I believe. Yeah. But no. And my great-grandmother never believed it, never believed that we went to the moon. She thought it was all just some sort of advertising stunt. To sell what, I don't know, but I never really talked to her about it. I was too young, but she thought it was dead set fake. So that's the one that stands out to me.
I was actually going to say the same thing, in fact. The
other one for me is flat Earth theory. Don't even want to go there. Don't want to go there.
It's really interesting that people the flat Earth movement occasionally has global conferences, which I think is quite an interesting thing. I've cheated, Andrew. I've just looked up my talk on fake news to find out the name of that phenomenon, which is pareidolia.
Pareidolia.
Yeah, that's the word, where we see things that look like something else, and we can't out of our head, like ducks down drain pipes.
Yes.
So I don't know. Yeah, look, we didn't go to the moon conspiracy. I kind of, even though Buzz has got a lot more reason for actually getting irritated by people saying that than I have, it really irritates me as well, because I lived through it. I followed them step by step, and it was the flavor of the time. Had the astronauts not gone to the moon, the KGB would have been on it, all over it.
Absolutely. And how could you fake it when there were so many people around the world involved? I mean, the simplicity of timing radio signals would have given it up straight away. So,
yeah, that's right. 40,000 engineers and scientists who are not good liars. No. The fact that there are 385 kilograms of stuff that came back from the moon, which we've analysed to death, and no,
they got that at Bunnings. You knew I'd get another Bunnings joke in, didn't you?
Yeah. Well, yes. Oh dear, I was there the other day, actually. The thing I bought there didn't work, but it wasn't their fault.
Oh, yeah, I've had that happen. Yeah. So there you go, Brody. We both agree on the fake moon landings as probably being one of the biggest bugbears in fake news. Yeah. All right. Thanks for your questions. And if you do have questions for it, we've got a whole batch of new ones, so I'll work my way through them. One small request, I don't know if it's possible, but I really have trouble with WAV files. We get them in different formats, but for some reason, WAV files and my computer don't like each other. But anyway, if you can send MP3s rather than WAV files, that would be helpful. But we can convert them. It's just my computer's going, no, you don't pay me enough for that. But if you've got questions for us, send them to us via our website, spacenutspodcast.com or spacenuts.io. Just click on the various links or the AMA tab to send us your audio question. And don't forget to tell us who you are and where you're from. And while you're there, have a browse around the Space Nuts shop or the supporter page or whatever you like. Maybe you'd like to become a patron. That's totally up to you. We'll never make you do it. It's 100% voluntary. That brings us to the end of the show. Fred, thank you very much.
It's a pleasure, Andrew. Well, I think it is anyway.
I really enjoy it.
Yeah, of course it is. No, I'm joking. I'm just still wound up about people not going to the moon. It just gets me every time.
It's been a big one for a long time. All right, thanks, Fred. We'll catch you on the next episode.
Sounds great. Take care.
Fred Watson, astronomer at large, part of the team here at Space Nuts, and to Hugh in the studio, if he was there, but he doesn't exist. He's fake. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.